Okay, on number 1, it says to name the properties. So let's see what's happening. If I tell you measure of C is 30, and then I tell you 2 times measure of C is 60, what operation did I just do from the initial? Multiplication property of equality. Make sure your symbol equal or congruent to matches the given. So we have segment AF is congruent to itself. What is that called? Reflexive. If you look at yourself in the mirror, hopefully that is you. And then we have our most often used property. YZ is equal to BD, and that same BD equal to JK. So therefore, YZ is congruent to or equal to JK. What was that? Transitive property of who? Ooh. Equality. The symbol must match. And then on part D, what are we doing on from the inside to the outside? Distributive. Uh-oh. Butive. Property. It's not happening on both sides, so it should not be of equality. All right. Moving on to number 2. What kind of proof is number 2 called? Is it algebraic or geometric? Algebraic. So let's write the given. And then we write the proof at the where? At the very end. Okay, what is the first step from 1 to 2? Subtract 4. Let's physically do that. So we get 2x is equal to 4. So we have subtraction. Property of equality. And then what's happening from 2 to 3? Divided. So we have division property of equality. Okay, let's go on to the other proof. What number was that? 13? Okay, how many givens did I give you? 2. So it looks like my given is down here on number 4, and then we have 1 on the beginning. So the second given, let's write on number 4. Angle 3 is congruent to angle 4. Okay, let's analyze the picture now. So we know 1 is congruent to 2. That was by the given. And then what do we see on the next reasoning as a hint? Vertical angle. So angle 1 and what is vertical? 4. So that means angle 1 goes here, is congruent to angle 4. And our most often used property transitive. So let's analyze this one. From 1 to 2, what has been repeated? 1. So we know our result is that angle 2 is congruent to who? Angle 4. And that is transitive, correct? Okay. Can I use transitive one more time? Okay, what 2 am I going to compare? 2 and 3? 3 and 4? Let's see. 3 and 4, what's repeated? Angle 4 is repeated, so I have 2 and 3, which I have. Transitive property of congruence. Okay, let's do a recall on our conditional statements or the symbolic notations of them. Conditional was what? P then Q. Converse was Q then P. And what was biconditional? P, arrows on both sides, if and only if, yes. Q. If you want to say if and only if, go for it. And inverse will be not P, then not Q. And then contrapositive will be not Q, then not P. So let's write the statements and see if it's true or false. Brian, let's read statement number 1. If
angle C is obtuse, then M angle C greater than 180 degrees.
kind of want to modify this. Let's call this 90 degrees. So if I have an obtuse angle, is it true that it has to be greater than 90? Okay, true. Let's write the converse. I'm going to say the converse and not physically write it, okay? But for y'all, go ahead and write it. If the measure of C is greater than 90, then is that angle obtuse? Okay? Okay, I'm going to say the biconditional part. For the biconditional, you do not say if at the beginning. So here I go. Angle C is obtuse. If and only if measure of angle C is greater than 90. So listen and write. I'll say that one more time. Angle C is obtuse if and only if measure of angle C is greater than 90, which is also true. Okay, if you're ready for the inverse, give me a thumbs up. Okay, I'm gonna wait 5 more seconds. For the inverse, if angle C is not obtuse, then measure of angle C is not greater than 90. If angle C is not obtuse, then the measure of angle C is not greater than 90. And that is also true. For the contrapositive, if the measure of angle C is not greater than 90, then the measure of angle C is not obtuse. If the measure of angle C is not greater than 90, then angle C is not obtuse, and that is also true.